Hello. Today I'm going to demo Concerto with LXD. LXD is a lightweight VM runtime, which unlike other VM technology, for example VirtualBox, you don't have to provide it 8 gigabytes of memory up front. So for my demo, I want to create a couple of clusters of 5 machines each. That would be difficult for me to do on a standard VM system like VirtualBox. Instead, I can do it easily and with no pain using LXD, where each instance, for example, has its own IP address. It can run its own SSH server, so on and so forth. Um, so that's where we're going to start. Now, there's one caveat to this. LXD is very much a Linux tool. Um, so you're not going to be running this, I don't believe, on your MacBooks anytime soon, or Windows for that matter. Uh, Obviously, maybe on a subsystem like WSL. However, you'll be messing around with bridges and so on and so forth because the demo does require that the LXD instances have access to the internet. Okay, we'll get started. Okay, so here we are in the control plane for this application. Currently it's empty apart from concerto.jar, and in fact I'm just going to remove that install script which was for Babashka. So concerto.jar, this is the the startup of an application. Now I'm going to remind you here of one thing. Here is the help section, and what I'd like to note right now is there are no extensions. So as we install what's called the starter pack, you will find that the it will bring down extensions with it. Okay, now / concerto starter pack. One thing I'll just say quickly here: starter pack is not in this list of commands, and yet I can call it from here. There's a if you remember, concerto is a bootstrapping script, and it the bootstrapper in this instance is providing starter pack. All these other commands, all this help section comes from the jar file. So there's a wee bit of a split of responsibilities there. I have there are two commands in the bootstrapper, which is update and starter pack. I'm not intending to put much in there. They may move around, but that's where there are. That's where they are right now. Anyway, Concerto starter pack. I'm going to untar the starter pack and remove the GZ. Okay, yes. Okay, and so that downloaded the starter pack, and now we find in this directory you have the a basic concerto setup with the extensions directory, scenarios, services, targets being the main directories which comprise a concerto application, and then scripts as just a higher level script tweaks which call the plumbing underneath the concerto plumbing. Now, if I run concerto again, you will now find that I have extensions. Extensions are organized by directory underneath the extensions directory, and I'll talk about these in detail in another video, but that's not my purpose now. My purpose is to create a couple of clusters and actually have them do something. Okay, so I'll start off by using one of those extensions, because the first thing I want to do is create I'm going to take this. I want to create a base image for all the nodes in my new clusters. The base image is going to have Podman in it. It's going to have a SSHD server. And indeed, I will show you in the documentation what the basis of this is. If I come to the documentation here, we should find somewhere in the documentation prerequisites. Yes, manage nodes. Each of the managed nodes, or all the nodes in the cluster, this is the Cloud Init spec that I'm using for the nodes. Okay, so I'm creating a user concerto, homed our concerto. He's going to be a member of the concerto, is a member of the sudo group. He can use no password to install things. Here are some commands that I'm running as it boots up. I'm installing OpenSSH, Podman, sudo, Python stuff, making sure SSHD starts at boot, and then installing Podman Compose. Further, everything's over the private public key. Here is the public key, which will be added to known hosts. Using obviously Cloud Init for this kind of thing is terrific, and also it enables me to specify and talk to you about it very easily. So that's what's going on when I say /concerto and I call that extension. Okay, it's going to initialize a base Alpine image with this stuff here. It's an Alpine image with this, and it also adds metadata into the LXD itself so that we can get a list of the machines later on. Okay, now with that I will start this off, and as it does its work, it has to go off to the internet, download Alpine, do its stuff, download all these things. I will pause and come back later. Okay, now that process is finished. It says an error image not found. I should provide some better messages when that goes through, but the error image not found is not really an error. The part of this setup is that because I was doing this regularly, I was deleting the old concerto image, which I'll just about to show you, and it didn't find it on this clean setup. So let me just show you some LXC commands. LXC image ls. What we just created there was the concerto image. Is based on Alpine Cloud, and as that setup script runs, as the concerto demo cluster base image script runs, it tries to delete that. If it's not there, then that throws that error. I should provide some better messages in there. However, that's been successful, and I'm going to pop up. I'm just going to use that concerto image. I'm going to now create or launch a Woot instance based on concerto, because I just want you to see what's inside a managed node real quick. So LXC launch concerto base image called Woot. It's going to unpack that, and now I will exec. LXC, just like you've got Docker exec, LXC is a LXC exec, which takes you into actually just before I do that, just let's do LXC ls, and you can see I've now got Woot running, and it has an IP address there. So that's pretty nice. You know, if you could have 20 or 30 of these on a small machine, it's a great for simulation, isn't it? So that's running. Let me just exec inside it, and does it have Podman installed? Yes, so Podman is now there. I don't think I think I have top here, and with top you can see it's running SSH D. Okay, now I can LXC. I can afford to be ruthless, so I'm going to LXC delete woot, just get rid of it now that you've seen it. And now we're going to try one of the other demo commands. So let's see what we've got. I'm now going to create a cluster. Okay, just before I paste that in, let me just say lxcls again. You see I've got nothing, no running nodes. Okay, so let's now concerto and cluster create west. I'm going to call the cluster west and let it go. Shouldn't take very long. And now we have a look, lxcls. We now have 5 running containers. We have 3 API machines, 1 balancer, and 1 DB. Hey, there you have it. And let's do another one. Let's create cluster east. lxcls. 10 machines. Wow. Okay. Let me just show you a few things here. Well, first of all, let me just run through. Well, yeah. Let me just run through another cluster command before I get on to. Again, just for the purpose of demonstrating how lightweight LXD is, let's just remove everything. LXCLS. Oops. Boom. You gotta love it. Okay, so I'm just I'll recreate those 2 clusters again. Okay, so I've recreated those clusters. Now, in the demo, I've set up the live target to access the LXD instances, and that access is dynamic, and that's quite an interesting example which I'll take you into later. And I think I'll briefly show you now, actually, because just to tweak you, but let me just show you the tree first. Okay, so here we have the targets. I've got targets live, local, and stage. So these might be a typical setup that you may have. You'll notice now you can, for example, specify machines declaratively using EDN, or you can specify machines programmatically by machines.clj. What I'm going to do right now is just quickly show you machines.clj to show you that it's accessing the extension, the LXD extension, to get a dynamic list of machines. So let's just look at that real quick. Cat, I'm in there, so targets live machines.clj. So it's namespaced as targets live machines, and you can see that it's importing extensions, demo, LXD extend as LXD, and the source function would return a list of, or a sequence of machines with the attributes, or a sequence of maps with the attributes IP, role, cluster, and I've forgotten the other one. Cluster, IP, and host. That's what it is. Um, but it's dynamic. That's the main thing. So this particular live instance or live target is using a dynamic list of machines, and this shows you that maybe you're calling out to a database to get your list of machines or however you're doing it, but you can dynamically create your machine lists. Okay, as the Concerto user, you can then start to do things like this. So you can now begin to query your machine list by, in this case, role, or you might select by cluster, or you might select by cluster and role. Right. So in this way, you can get what you need from that dynamic list that's been generated dynamically. You can get it. That's the default is Eden. You can get it in JSON, or if you wanted, you could just get a list of IPs, or whatever the IP host, which is great for your scripting. If you want to do higher level scripting and just get some information. Okay, I'll leave that there and we'll move on.